Today I am in Lawton, where they produce solid end mills from Seco. And I also question on Instagram, what is the most common issues when shoulder milling? And the most common issue is no doubt shatter. So we will discuss some of the issues here today with Seco stuff. Here we have Rob, he's the
Hello.
product manager for solid end mill. And we will be discussing some of the issues we had. Shatter was one of the most, it was the most common issues that people have with shoulder milling.
Yeah.
Can you tell me something about that?
Yeah, sure. Chatter indeed is a quite common issue, and it happens a lot when you have very high metal removal rates, or if you have very long protrusion lengths where the tool is sticking out of your tool holder a lot. Then indeed chatter can occur very lot. Or also if you have a not so rigid tool setup, where either the tool holder or the clamping device is not as rigid as you want, then chatter can occur.
I know some people think it's a bit too slow sometimes, they want to remove more. But obviously shatter is the issue here on the surface, of course. So do you have any good tips?
Yes, and it's not necessarily that you need to reduce your feet and speed in chatter. Chatter is quite a lot about harmonics as well. So if a tool comes into its own harmonics, then it can start vibrating. And you can test it very well with the harmonics by testing the harmonics sweet spot. And that you can do by tapping with a vibration tool on your tool, and then you can see a nice curve how your vibration looks like on your tool. And then from there on, depending, you can select your tool feet and speeds.
Yeah.
So, and other topics to include is also if you add certain features on your end mills, like for instance an unequal pitch or unequal helix angle, so to make the geometry unequal as possible, because that also reduces the vibrations or the chatter. And you always need to look, of course, to your tool setup. So make sure that the tool is mounted properly in your workpiece, as you have as short as possible protrusion length, and also your workpiece is set up well in your machine.
Yeah, I guess run out is also an issue.
Yeah, sure.
So ship jamming and recutting ships is very common in pockets, for example. Do you have a quick solution for this?
Yes, in pockets the main go-to solution is chip breakers, reducing the chip length, and also through coolant channels, which you can either use with coolant liquid or air blast to remove the chips from your deep pocket. Other solutions will be to reduce your feed rate to prevent the chip to have smaller chip thickness, and also otherwise you can look into your geometry to have a better chip room, so more chip space in your end mill by, for example, reducing the number of flutes in your end mill. So those
also helix angle maybe?
Yes, helix angle. If you have a sharper helix angle, the chips are being pushed upwards, and then especially in close pockets, a sharper helix angle will help you removing chips. But you need to make sure that your tool setup is done properly to prevent tool pull-out.
So the helix angle, when should you choose what, so to say?
It depends. Helix angle, the stronger your helix angle is, the more the forces will go from radial to axial up into your spindle. Nowadays, a lot of tool clamping devices can handle that, and then a sharper helix is the preferred go-to route. But there are also, if you have an older setup or a not so strong setup, then it can happen that your tool will pull out of the machine or your workpiece will pull out of the holder. So that are always topics to consider.
Is it especially to think about when you choose materials? Is it like titanium versus aluminium? Is it?
In most materials, it helps pushing the forces upwards and into your spindle. But there are, for instance, in glass fiber materials or laminated materials, there you get delaminating if you have a too high helix angle. So there you want to have a more flatter helix angle, or maybe even a compression tool where you push them towards each other to keep the laminating together.
So rake angles, would you say it's like similar kind of application for rake angles, or?
For rake angle, it mainly depends on your workpiece material. If you have a sharper rake angle, the cutting process is smoother, you need less forces, but also your flute will become weaker. So if you make a cross section of the tool and you have a very sharp rake angle, then the flute itself is smaller, so it will be weaker in very hard materials. So for hard materials, you need a more neutral or even negative rake angle, and for very soft materials like aluminum or even plastics, there you need a very sharp rake angle to get through it quite smoothly.
Yeah, it's like the bigger the core, the
Yeah.
stronger the tool.
Exactly. Yeah. Well, what applies for the core also applies for the flute. If you make a cross section of your flute and you have a very sharp flute, then it is not as strong as when you have a flatter rake angle.
A question that one of the followers asked is, what is the main difference between solid end mills and indexable cutters, basically? Why should you choose one over the other?
The main answer will be on cutting diameter. Solid end mills are made of full carbide, and they usually range from a very small diameter like this one, 0.1 millimeters, up until 20-25 millimeters. Whereas an insert mill varies from diameter 16 and upwards to 160 for square shoulder milling, even bigger for face milling. And then in between, we now also have our XZ solution, which varies from diameter 10 till 25, but is usually for very deep pockets or long overhangs and for lighter types of cuts. In solid end mills, you have an end mill which is directly into your tool holder. If you then have a high precision collet chuck, your tolerances are fairly small, also the runout is small, and with that you can do more precise types of cuts with less runout, with less vibrations, and also for instance finishing applications.
Yeah, so it's a good solution to a lot of problems as well.
Yeah, it really depends on your application. If you have a big machining envelope and you need to rough out a lot of materials at once, then insert machining is the go-to. And if you are in smaller pockets or need to do more fine machining applications or finishing, then you can go for XZs or for solid end mills. Yeah. And XZs is your in-between solution.
Also, I have the problem with the spindle speed, so I can't really utilize them for roughing as a lot of people do. I know high-speed machining, for example, they use very high RPMs to rough out material, which is very quick actually.
Yes, so indeed, and in both directions you can gain your high metal removal rates, but on a different way. Yeah. So it depends on your machine setup, on the type of workpiece which you have, which solution would be the best for your application.